Hi, welcome back to Security and Privacy in Cloud. I'm Jay Lavanya, Assistant Professor of CSE Department. So in this Unit 3, we are going to discuss about the access control and identity management. Under this, we are going to see the topic called OS hardening and minimization. So what is meant by OS hardening and minimization? So OS is nothing but operating system, right? The realm of cybersecurity. Hardening and minimization are the critical practices aimed at reducing vulnerabilities and enhancing the various things and security posture of the system. And this document explores the essential strategies and techniques for hardening and minimizing operating system, ensuring they are resilient against potential threats and attacks. By implementing these kind of practices, organizations can safeguard the data and maintain the integrity of the environments. So this is the type of OS security which it has some strategies, access control, and the patch management. And the security posture, we can able to give the data protection or the threat detection. And another techniques, we can able to use some configuration management or the service disabling and organizational practices like policy enforcement and training and awareness. We can able to avoid these kind of vulnerabilities in the OS. So what is meant by OS hardening? So it refers to the process of security in operating system by reducing its surface of vulnerability, and this involves configuring the system to limit the exposure to threats, applying some security patches and removing some unnecessary services and applications. And one more thing, OS hardening has some best practices which is followed. Like as I told, it's a type of system hardening where it is a process of implementing security measures in whether Apple OS or Linux or Windows. The goal is to protect some sensitive computing system, reducing the system's attack surface in order to lower the risk of data breaches, unauthorized access, or system hacking, or some kind of malware. So what kind of tips from experts? What they say is that the benefits of hardening OS is that improving the security and reducing the system's attack surface, minimizing the computer's exposure to the threats or lower the risk of data breaches, unauthorized access systems hacking or malware, protect the sensitive computing systems that run some mission critical workload or store some sensitive data, supports compliance with the industry specific regulations and standards, and increases the system stability and reliability by removing some unused services and applications, minimizes the IT support cost and frequency of support calls due to fewer security incidents. And what are the 15 OS like hardening processes then? It uses some OS updates or some service packs, patch management, removing unnecessary applications and services, turning on only the ports and the services required, or you can go for some secure configuration where we have to establish some fixed access rules or limit the creation of some user accounts and regularly review the accounts group policy. For additional security measures, you have to use some firewall configuration and hardening framework and endpoint protection and data and workload isolation, encrypting the HTTP and SDD that stores the OS. And so these are the OS hardening process. And here you can see the OS hardening process some diagram where a vulnerable OS will be there and we can able to apply some security patches and we can able to identify the vulnerabilities and we can able to remove some unnecessary services. Okay, so this is how we could able to calculate the process involved. And in Oracle, what they define by means of these kind of OS hardening processes that where I'll just show from the upcoming slide. So the key steps before that, I'll just say the key steps in OS hardening. First one is that patch management. Second one, user account management. Third one, service minimization. Fourth one, firewall configuration. And fifth one, security policies. And last one, logging and monitoring. So what is meant by patch management? You have to regularly update the OS and install applications to protect against known vulnerabilities or automated patch management tools which can help streamline this process. And in user account management, we have to implement the principle of least privilege by ensuring users have only the permissions necessary to perform the task, disable or remove some unused accounts, and disable or remove some unused accounts. And in service minimization also, it reduces some services and application that requires for the system's internet function. This reduces the potential entry points for the attackers. And in firewall configuration, it utilizes the firewalls to control incoming and outgoing traffic and configure some rules to allow only necessary traffic and block all other connections. And security policies that it establish and enforce some security policies that govern the user behavior, password complexity, and access control. And regularly, you have to review and you have to update the policy in logging and monitoring. It enables logging to track some system activity and monitor for suspicious behavior. And you have to use some intrusion detection system to alert the administrators of potential threats. Okay, so this is all about the key steps in OS hardening. Next, we are going to discuss about the OS minimization. So OS minimization, it involves stripping down the OS to its essential components, thereby reducing the attack surface. This practice is particularly useful in environments where only specific functionalities are required, such as in embedded system or cloud deployment. If you take in Solaris OS version was used to build the portal service on the application server. However, the architecture implemented is expected to be the latest version of the Solaris 10. For example, like most implementation in the Solaris 10 OS, the reference configuration portal service will be exposed to the internet or some other public or untrusted network, which makes minimization especially important. And if your portal service will be exposed to these conditions, you must reduce the Solaris OS installation to the minimum number of packages that are required to support the portal service components. And minimizing the OS you use for the portal service involves the following, like minimizing the Solaris OS on the computers that will be running the portal service component. Second one, hardening the Solaris OS on the computers that will be running the portal service component, and where we have to use some Solaris security toolkit which hardens the system by changing the system parameters, disabling any unused services, and providing a quick package like additional package like some WCTPLS or some WMF run or some WP15Q. Okay. So here, these are the phases of OS minimization, like essential components or reduced attack surface and specific functionalities, and then embedded system, and then cloud deployment. And before that, I'll just explain about the OS minimization, where uh, we have to go through so many Netflix or whatever thing in OS hardening or system hardening, we used to say. And here also, the Defense Information Systems Agency, security technical implementation, what they did is that they securely set up and maintain the ITSS or some technical implementation guide that focus on some configuration practices and types of system hardening like OS hardening, like server hardening, software application hardening, OS hardening, network hardening. Okay, the elements of system hardening is that uh, here hardening process begins by evaluating system and network to understand the primary needs. We have to don't overlook the components such as BIOS, firmware, and install software as attackers target all these to find the weak link that will get them in. And once the evaluation is complete, you can then begin the process of looking down configuration using standards such as NIST, CIS, and DISA to reduce the threats. And maintaining a balance between functionality and security is crucial. While security is a paramount, the hardening policy must address the cybersecurity need that IT team can implement as a proper balance between the components. Okay. So one of the techniques of OS minimization is that secure um, custom installation, containerization, virtualization, regular audits, and use of lightweight distribution. In customer installation, during the OS installation process itself, you could select only the components and the features necessary for the specific use case. We have to avoid some default installation that includes some unnecessary software. And what is meant by containerization is that user container technologies to isolate the applications and their dependencies. This allows for a minimal OS footprint while maintaining functionality. Virtualization, we have to deploy the virtual machine with only the required resources and services, which can help in creating a more controlled and secure environment. And regular audit is that conduct regular audits of the system to identify and remove some unnecessary files, applications of the servers that may have been added over the time. And use of lightweight distribution, we have to consider using some lightweight OS distribution and a design for minimal resource usage and reduced attack service. An essential element of system hardening is that locking down configuration or balancing functionality and security and vulnerability management and then change control. And the top benefits of using system hardening is that stronger security, a better system functionality, and simplified compliance. And then already, what are the system hardening best practices? Is that a system hardening which involves multiple layers and aspects within your IT infrastructure. Following these practices will help you protect against some vulnerabilities and cyber threats. First one, a user account. The cyber attackers often exploit a vulnerability in the user's account to gain access to IT system. User account hardening reduces cyber security risk by identifying and removing unnecessary user account. So it also involves a common target for threat actors in user account, with some privileged account being the keys to the kingdom. And some strategies like we have to implement a user account policy that defines the type of account that are allowed and creating secure password policies that enforce the latest password complexity recommendation. We have to restrict access to the privilege function. In file system also, like we have to enhance some system security by providing some permissions on files and directories. And we have to protect the data by encrypting both the transit and at rest and limit the access to potentially harmful file types. And uh, it also has some specific requirements and applications where we could be able to protect it. And what is meant by OS minimization is that, so here in OS minimization also, it reduces the size and complexity of an OS by removing some unnecessary components, focusing on some core functionality. And why we have to minimize this OS is that a smaller OS footprint means fewer potential attack vectors and vulnerabilities. and minimizing an OS which reduces the memory and storage requirements, which leading to faster boot times and better overall performance. And specific use case, minimizing an OS reduces the memory and storage requirements, leading to faster boot time and a better overall performance. And specific use cases like tailoring an OS to a specific purpose can optimize the performance and resource utilization. And what are the techniques of OS minimization is that optional features or the language pack and then the default application. And why we have to optimize the image, like in you have seen in some Amazon images where we have to just download and you have to compress the file and then only you can able to upload. Like similar to that also, a single instance in OS minimization also uh, to capture the changes to the OS into some compressed provisioning package for use by automatic recovery tools, and hard drive optimization also, which have to ensure a sufficient hard drive space for the OS and applications and minimum host OS footprint, restrict the user access to the system to reduce the attack surface. Do not run containers as a root. Example like a minimal OS, embedded system, and server environment. Distributions like Alpine Linux, Code, and Colibri OS are designed to be very small and efficient. OS like Free, RTOS, and Sapphire are designed to resource for resource-constrained environments. And server environment distributions like Ubuntu Server and CentOS are optimized for some server workloads. Okay, and next is that like there are so many minimizing OS like for the portability, some people will be using some cases or some kind of things. And next we are going to discuss is about the real world example. Here in web servers, there will be a scenario. In OS hardening, you have to use a disable uh, root login, and then we have to enforce some secure socket hash key authentication, and then you have to use some firewall rules in which the OS hardening will be working. And similar to that in OS minimization, if you're going for some Linux in web server, we have to use install only NGINX and essential tools. And apart from that, this will won't work. Yes, so that's the thing. And next is that we are going to discuss is about database server in Windows. So here it will be like it uses some restrict some database and DB ports and audit logs, and also it noise minimization removes the game apps or media apps and extras. Okay, in Cloud EM in Ubuntu, if you are using OS hardening, what they'll be doing is auto security updates like you have to be firewall or some strong passwords. So these kind of there are so many types of firewall, right? And next like base image with only some core services. Okay, and what are the benefits of using like OS hardening and minimization is that a stronger security, that means hardening minimizes the attack surface, making it harder for attackers to exploit vulnerabilities and gain unauthorized access, reducing the risk of data breaches, malware, and other cyber attacks. And better system functionality is that by removing unnecessary programs and configurations, hardening can lead to a more stable and reliable system with a fewer operational issues and incompatibilities, and simplified compliance and altering. Second benefit is that a hardened system with fewer account and programs is easier to audit, right? So reducing the time and resources required for compliance effort. Third one, improved incident response. A smaller attack service makes it easier to detect and respond to the security incidents, and better resource management like hardening can lead to more efficient resource utilization, potentially resulting in better performance and lower costs. And drawback, if you take like decreased convenience, hardening measures such as disabling unnecessary services or the features can sometimes make the system less user friendly or require more effort to manage, and increased complexity Implementing and maintaining a hardened system can be complex, requiring specialized knowledge and resources. Potential for conflicts is that hardening measures can sometimes conflict with other security tools or software, requiring careful planning and testing. Increased cost hardening can lead to increased cost due to the need for some specialized tools, training, and some ongoing maintenance. Okay. So this we have seen about the OS hardening and minimization, and what are the various types involved, and what kind of key steps followed, and what are the types of or the use cases of all this OS hardening and minimization. And we have seen nearly 6 steps in hardening and techniques to be followed in OS minimization in the real world example, and the benefits and harm, I mean benefits as well as the drawback in this involved. So I hope we have a clear idea about the OS hardening and minimization. So thank you all. We'll see you in the next video. Bye.